to talk about what can we do to improve the quality of front-end code. And in this case, I'm assuming we are writing JavaScript, but you could be writing, for example, TypeScript, which eventually compiles down to JavaScript. So the concepts are fairly the same, whether you're using JavaScript or TypeScript, even though I'm going to be using JavaScript as an example here. So let's talk a little bit about the quality of code and JavaScript. So sometimes you may wonder, is it possible to write good quality JavaScript? You may actually wonder that, because we are all used to so much JavaScript out there, a lot of bad JavaScript you're probably evidenced over time, and a lot of examples we see on the web as well ends up being quite a bit of mess, if you will, that we have to deal with. So essentially, the answer is yes, we can take the time and write better JavaScript, and that's what I want to focus on today. When it comes to JavaScript, our front-end code, there are two separate things we can benefit from. We can benefit from the general software principles we often talk about, and by applying those principles, we can write better quality code. Now, those principles, of course, are not really specific or restricted to JavaScript. You can use this in any language, so it applies to JavaScript as well. And we definitely should make use of those when we write the code. But on the other hand, there are a few things we also need to be very careful in how we write JavaScript, because that can lead to much worse JavaScript if we're not careful about. So I'll talk about some of those things here as well, and we'll take a look at it. So the first thing, of course, is what about good software design principles? The trick about principles is we can often talk about these principles, but we got to be very careful how we use those principles. If we misuse the principles, it can be leading to complexity as well, so we have to be very careful about it. So what are some of the design principles we often talk about? Well, the first one is cohesion. And what is cohesion? Cohesion is where like things are together. And cohesion is where the code is narrow, focused, and does one thing really well. So we want to make sure that the code we're writing is very cohesive. So when it comes to cohesion, let's think about, what does it mean to be focusing on cohesion? Let's think about writing a function. Suppose that function is doing many things, right? So for example, the function is doing many things, let's say access database, for example, compute, let's say compute tax. It also updates UI, and so on. Well, if a function is doing all of those things, what's going to happen? Well, this is really often termed with a slightly different name, which is called the single responsibility principle. So single responsibility principle and cohesion have a lot in common with each other. But it's more than a single responsibility. You want to think about it as a single reason to change principle. So the idea here is you want it to have a single reason to change rather than having multiple reasons to change. But why do we want a single reason to change? So if the benefit of this is the frequency of change is less if the code is cohesive. So essentially, if the code is more cohesive, you're going to change it less often. Now, what is the benefit of changing a piece of code less often? It's not just about just the less often, but if the code is changing many, many times, but if it's changing for multiple reasons, then that code is going to be hard to maintain over time. But if it changes less frequently, and when it does change, the intent of that change is one specific thing, and it becomes easier to focus on that change and make the change. So if a code is doing multiple things, you have to step over the parts that are not relevant and only make the changes to the parts that are relevant. That takes more effort as well. So as a result, you want to really make things very cohesive. Now, this can be very confusing oftentimes. And one of the problems oftentimes is when we talk about the single responsibility principle, we often have a really hard time understanding the word responsibility. So what does the word responsibility really mean? That is very confusing oftentimes, and as a result, we end up making wrong decisions. So I want to expand on that a little bit, little later on, and I want to go beyond single responsibility principle and focus on a few more things. So we'll get to that a little bit later. One of the other things we often talk about is the DRY principle. The DRY principle stands for every piece of knowledge should have a single, unambiguous, authoritative source of representation. So essentially the idea of DRY is you're not duplicating the logic or the code that is going to perform a certain logic or a rule in multiple different places. Because the more we duplicate the code, the more we have to make changes in multiple places when a change has to happen, and that is more expensive. But it's important to keep in mind that DRY is really not just duplication of code, it's actually duplication of effort. So if you're modifying code, that's DRY violation, but it may not be just modifying the code. It might be an effort that gets duplicated in multiple places. That's a violation of DRY as well. So for example, if you modify a code in one place, as a result of that, you got to make a change to a different code elsewhere. That rippling effect may be a violation of DRY as well. So you may want to keep an eye on the DRY principle. Again, a lot of these principles are really nice, but like everything, we have to evaluate and decide if it's a right thing to do or not. So much like everything else, any principle, you can say, when used, you could say, when used correctly, leads to a better design. If used, incorrectly, or when not necessary, it leads, unfortunately, leads to unnecessary, unnecessary and excessive complexity. So essentially, unnecessary complexity, and you're going to be dealing with this complexity, unfortunately, because you're using a principle when you don't need to really use the principle. So you have to be very careful. Like I said, these principles apply to any code we write, not just JavaScript. But it's no exception that you will not use these in JavaScript. You want to think about these for JavaScript as well and use them for JavaScript code also. So now let's dive a little bit closer to JavaScript itself. So the first thing I would say here is a few things you want to avoid. So what are the things you should really avoid when it comes to writing JavaScript? Let's give it a try. Let's say you have you have a equal to 1, and you have, let's say, a b equal to, let's call this as a 1 point, let's call it as a 1, like so. And let's say we also have a c, and let's make it a 1.0, if you will. So when you look at this a, b, and c as the values you want to consider, and in this particular case, well, actually, how about this? Let's say a is a 1, like in a string 1. Let's make b as 1, like so. And in this case, we have a c, which is maybe a 1.0. We can think of these different values you could consider, right? And in this particular case, what if I were to say this is a 1.0, like this is a string, let's say. Now I'm going to ask the question, is a is equal to b? Let's see what it tells us. Now in this case it says true, a is equal to b. I'm going to ask the question, is b is equal to a value of c? And it says it's true. Now I'm going to ask the question, if a is equal to c? And when I run the code, notice it says false. Now, my recommendation is, if you have small children at home, don't show this code to them, because they're going to lose all the faith they have in our field, right? Because what did they learn? They learned about this law of being transitive, right? So what does transitivity say? If a is equal to b and b is equal to c, then a should be equal to c. And JavaScript says, not really. So that is really confusing. And so what went wrong? Well, what went wrong here is we need to really understand what this double equals really means. And the double equals really means not a compare, but it actually means cast and compare. So it's converting the types and comparing it. That is what it really is. So convert and compare, not just compare. So the question you want to ask is, did you really want to convert and compare, or did you just want comparison? That's the question you want to ask. So when you run the code, you can see it's a true, true, and false, which is not really helping us. So the moral of the story is, do not use double equals. Instead, use triple equals. So back here, I want to say a triple equals like so, and notice it's false for all of those things. But that's because, what does a triple equals do? This is simply a compare. There is no convert operation in there. So the moral of the story is, if you're writing JavaScript, you should use a triple equals for comparison, not a double equals. In a similar way, you do not use an exclamation not equals. Instead, use exclamation double equals. So that allows you to do a not equals comparison in a proper way, and that again will compare without converting. But let's be fair about this. This is easier to say, but how many of us program in JavaScript here? Raise your hand. Okay, keep your hand up. How many of you only program in JavaScript and no other language? Not many hands stayed up, right? Because we program in multiple languages all the time. We don't program in JavaScript almost exclusively. How many of us program in Java? Okay, how many of us program in C#? Yeah, notice that we got common here, right? So we got people programming in Java and programming in JavaScript. We have people programming in C#, programming JavaScript. I often say JavaScript is like the English. Why I say it's like English? Because almost everybody speaks it, and they speak it with a terrible accent, right? So that's kind of why JavaScript is. So everybody speaks English, but everybody has a different accent, and we all introduce our weirdity. That's how JavaScript is. But also JavaScript is a universal language, so to say. I had a company in Denmark, and they said, hey, come and teach a course on software design. I'm like, oh, I'd be glad to. And we accepted everything. We decided on the date, everything. And then 2 weeks before the course, they sent me a frantic email. And they said, oh my gosh, we totally forgot to mention this to you. This is going to be a problem, I think. We found out that the class contains 3 groups of people. 1/3 of the people in the class are going to be Java programmers. The second group of people in the room are going to be, C# programmers. The third group are going to be PHP programmers. How in the world are you going to teach a design course for Java, C# and PHP programmers in the room? And I told them, yeah, don't worry about it. I'll take care of it. And then I started thinking on the way over there, I mean, how do you really do this? If I use Java, 2/3 of the room is going to be angry with me. If I use C#, the other 2/3 of the room will be angry with me. And then I finally realized, if I use JavaScript, that's the best option. Then everybody will be angry with me, right? So that works really nicely. And that's exactly what I did. So I chose a middle language that anybody in the room will understand. So that becomes a nice way to really, use it. So what I'm getting to with this is, it's easy to say use a triple equals, but when you program in Java for some time and JavaScript for the rest of the day, or C# and JavaScript, your brain is not going to switch over typing 2 equals and suddenly typing 3 equals. If you're like me, you're going to miss out on using this, and then the code misbehaves. So what do? Well, this is where we can really rely upon tools that can help us. So what I would recommend is, you want to use almost always, you want to use ESLint with your JavaScript. And in ESLint, you can configure an option that says, if you see a double equals, give me an error. And so if you use a double equals, it'll give you an error, and you can identify it and you convert it 3 equals. So as a result, you don't have to worry about remembering that. It becomes a lot easier to work with it. And that's what I would recommend that you do, is to rely upon those kinds of tools to make your life really easy, so you don't have to worry about remembering that kind of stuff all the time. Excuse me. So that's basically the idea, is to use a triple equals, don't use a double equals. All right. So then there is another issue that we need to be careful about. JavaScript is a language that's been around for a very long time. It's kind of scary, right? It has been around for more than 28, 30 years now, which is kind of scary, right? Can you imagine a language that's been around for that long? You say, yeah, Java has been around that long, right? Maybe even Ruby has been around that long. But JavaScript is a little weird. I was trying to describe what is JavaScript to somebody who doesn't know JavaScript. And my definition of JavaScript is this. It is like that villain in this bad movie. They keep killing him, but he keeps coming back to life. That's kind of the way I feel about JavaScript. It was never intended to survive this long. And JavaScript has a lot of these nuances that can trip you up. No, so Brendan Eich, the gentleman who created JavaScript, he once said he never expected anyone to take this language seriously. And all of a sudden, this is the language that runs the internet, right? And so then they said, we got to really clean it up. But in all honesty, you don't have the luxury in JavaScript that you have in other languages. In languages like Java, you can deprecate things, but you cannot do that in JavaScript. Why? Let's take example of Java. You can say, oh, I'm going to deprecate this particular feature. Well, you control what version of Java you're using, and you can clearly say, I'm using this version now, and I'm using this other version later. You don't have that luxury in JavaScript for two reasons. One, you could write a more modern JavaScript, but somebody out there refuses to upgrade their browser, which only runs old JavaScript. You know what I'm talking about, right? That browser, that'll remain unnamed here. And they are still adamantly using that browser. That browser will go away, only those people die. And that may be a while before that happens. So you can write modern JavaScript and throw it across, it's going to choke up on those machines. But on the same note, you may have a more recent modern browser, that's great. But guess what's going to happen? Somebody's got that very old JavaScript written and they have not updated that code. And your browser needs to pull and execute the JavaScript still today. It cannot say, I won't run that. So that's why it's not easy to just deprecate things and move forward. So what they did was something rather different and unique, is they left everything that was there as it is, hoping and praying we don't use that anymore. And they introduced new way of doing things on top of it. But let's understand what the problem could be in using some of these things. So the first thing here is, if you were to, let's play with this for a minute, right? So I'm going to say over here a function called outer, and the outer function, what does that do? It says for I equal to 0, I less than 5, I plus plus, and then it simply says inner. And then I have a function called inner, and the inner function says for I equal to 0, I less than 3, I plus plus, and then it simply says output, let's say hi. So a very simple code, right? But I'm too scared to run it. But let's see what's going to happen if we run this code. But what do we expect this code to do? Let's be logical about it. You're calling, in this particular case, the outer function. So when you call the outer, it goes in here and says, do this 5 times. And it calls the inner 5 times. And what does the inner do? It is printing hi 3 times. The last time I did some math, 5 times 3 is 15, right? So it should print 15 times. It should print hi, right? So let's go over here and run the code and see what it does. It didn't print anything. That's kind of sad. Let's go ahead and save it and run it again. Maybe I didn't save it. So there you go. And I ran it, and there's the output. Is that 15 times? Actually, as it turns out, I keep hitting the return key. You can see what's happening in the bottom. It keeps flashing right there. Maybe we can wait a little longer. What do you think? Eventually it'll finish, right? We could be here until cows go home, and it's still running and still running and still running. What just happened, right? So when you look at this code, you are kind of wondering what actually happened here. Well, what actually happened here is JavaScript looks at this code and says, uh-oh, look at what Venkat did. He forgot to define the variable I and used it without defining, how can I hurt him the most? And the best way to hurt, JavaScript never complains. It just takes revenge at you. So it said, the best way to hurt this person is to turn that variable into global variable, because we all know writing global variables is a bad idea. And so JavaScript says the best way you can never forget to do this is to hurt you the most. So as a result, it made that variable a global variable. Not a very good idea, right? But that's what it does. So in this case, if I say let I equal to let I and let I, now if I go back and run the code, notice it terminated at the end of printing 15 times. So the moral of the story here is you got to put a let. But of course, once again, what if I forget to do it? What can I do? The way to fix that very easily is to use strict at the very top. So it's written like a string, which is weird, but the reason it's written as a string is for the reasons I mentioned earlier. You may take this code and run it on a very old browser, and if you run it on an old browser, obviously they don't know the new concepts, but they're very clever here. They put it as a string. The old browser is going to take this code and say, that's kind of weird. This person put a string with no purpose and throws it out. He doesn't know what to do with it. A more modern browser says, hey, there's a loose string hanging, looks into it, it's a use strict. I know what you mean by that. So that's how they enforce the strictness as a string, and now you know the reason why it's a string. But when I compile the code, rather when I try to run the code, it gives me an error, I is not defined. And obviously, if I define the I right now, you can see in this particular case, it is going to know what that is and doesn't give you an error, and it terminates after printing 15 times. So you want to avoid global scope, global variables for it, and you want to be able to use a use strict. Now, here's another good news. You can use strict in your code. That's a good practice. But if you're already using JavaScript modules, you don't have to put use script, because modules automatically run in the strict mode, so you don't have to put the use strict. So if you're not using modules, use strict. If you're using modules, then of course you don't have to put use strict. So with that said, let's go a little further with this. You want to be a bit careful not using old constructs. So for example, if you were to take a little example, let's say a function sample, and in this case, I'm going to call the function sample like so. Now, I'm going to go back to this code and say a var local1 equal to 7. I want to print local1 right there, but I say var local1 is equal to, let's say 2, and I want to print local1. Now think about this for a minute. Why would you want to redefine a variable? It makes sense to reassign a variable, but it doesn't make any sense to redefine a variable. But yet JavaScript allowed you to do that. Not only that, if I were to go back here and open up a block scope, and within this I say local2 equal to 100, and then I'm going to output local2 right there. But then what I want to do here is, outside of the block scope, I want to print local2. When I run the code, notice it printed 100 the second time. What just happened? Well, JavaScript doesn't have the concept of block scope, at least did not. So as a result, when it sees this curly, it says nice curly and throws it away and doesn't do anything with it. So as a result, it doesn't have a block scope, or didn't have a block scope, which is a flaw, right? So you want to have a block scope because you don't want variables to leak over to other areas that can be a source of error. So what is the moral of the story? The moral of the story really here is quit using var, because var doesn't have a local scope. Var is also something you can redefine, which is not a good idea. Now, once again, you say, okay, that's great. I will not use var, but I have this habit. I'm going to type var because I'm used to it. Or I'm maintaining an old code and I don't want to continue writing var in the code. I want to modify it. What do? Once again, ESLint can help you. You can configure ESLint to give you an error if it sees a var, and as a result, you're going to modify it, and then you're going to move forward. And so that is one suggestion you can follow. So what do? Quit using var. Instead, use const or let. So I can go back here and say, let I equal to 1. Notice the error that you get right now. You cannot redefine local 1. So the minute you say let, the variable cannot be redefined. You can reassign to that variable, but you cannot redefine that variable. Likewise, if you were to define using a let, notice the error now, the line number 13, which is this line, has an error because you have a block scope. You cannot access local 2 anymore, because when you leave that block, the scope of that variable ends. So that is the benefit you get from using a let. So the moral of the story is use a let otherwise, and I'll see why otherwise in a minute. But the better answer is use const where possible. So use const where possible, use let otherwise. So back here, this is a let because I want to change it, but this should be a const because I am not changing it, as you can see. So in this case, you want to use a constant instead of a let. Once again, if you configure ESLint, ESLint will tell you that you should be using a constant and not a let, and that is much better. So your go-to should be a const, first of all. If you're not able to use a constant, then use a let, but don't use var. If you're using ESLint, you can configure it. If you're using a let where you should use a const, it'll give you an error. If you're using a var, it'll give you an error as well. So that way you can make the quality of code a lot better. So that is something I would highly recommend that we do. So we talked about some of the nice ways in which we can write the code, but the chances are we can write bad code and it becomes really hard to maintain it. Now, most of us, maybe even all of us, have really good experience writing code in the imperative style. And the imperative style is the most prevalent style of programming, but it turns out functional style code is less complex. It has less accidental complexity. The code reads like a problem statement. But by writing code in a functional style, we can make the code easier to understand. So where possible, I try to write more functional style code than to write imperative style code wherever that makes sense. But from the design point of view, is this just a syntactical difference? Is it just a style difference? Or there anything better to think about? And let's talk about that for a minute with a little example. But there's one thing you can do is you can say, I wrote a better quality code, which is nice. But you might be a team leader. You might be a technical leader, and you might want to have your team write better quality code. Now, how do you write better quality code? In the earlier presentation today, if you were there, Rebecca Parsons was saying, talking about fitness functions. Fitness functions are really nice because it gives us a way to know if we are heading in the right direction. You know, my doctor may say, hey, your health is not really good, you need to improve it. Okay, thank you, doctor, I will improve it. But how do I know in 6 months I am the same, I am better, or I am poorer in my health? How do you measure it? They can say, how are you feeling today? I can say, I'm doing great. Well, thanks for coming. That's not going to help really well, right? Yes, it's important to know that I'm feeling well. If I'm saying I'm not feeling well, that's a problem too. But just because I'm feeling well doesn't mean there is nothing wrong or something wrong. So how do you really determine that? Well, the interesting part of medicine is this didn't exist 200 years ago. We are living in a great times. Doctors and pharmacists and those involved in the medical field have figured out that human body has a lot of chemicals, and the chemicals are of different composition depending on our health. So they can measure my cholesterol number. They can measure my blood pressure as well. They can measure my glucose value, for example. They can look at my temperature. They can look at my height, my weight, and so on. And they can measure all of these. And I go to the doctor in 6 months. They can measure those and say, hey, your numbers are looking better, or your numbers are about the same, or they are worse, right? In a similar way, it'll be nice if we can measure that as well. So we'll do both of those in here and see how we can do that. So I'm going to go ahead and do a npm install here, and let me see if I have a connection here. Let's see if that works. So I'm going to do npm init first of all, and bring that little project here. So I'm going to say npm install, let's say save dev. I'm going to bring in a tool called Plato. Plato is a tool that will allow you to measure the quality of your JavaScript code. So that tool is called Plato, and I'm just installing Plato. That's all I did right now. So I'm going to edit right there the package.json, and here is Plato that has been installed, as you can see. I'm going to say Plato, and I'm going to run Plato right there, and I'm going to say -r -d report, and the source directory is what I'm going to look at. So I'm going to ask Plato to measure the quality of code in my source directory. Now, what am I going to do with Plato? So here is the idea. I want to use a tool to measure the quality of code. I'm going to change my code, and I feel like I have done a better job. I'm going to see what Plato tells me. And if I think it's better, and if Plato says it's better, that's a good win, right? But what if the tool disagrees with my assertion? I will change the tool. That's the only fair thing to do, right? No, just kidding. So using the tools can be a nice way to get this feedback loop going. So we'll come back and take a look at this in a few minutes. So I'm going to go back, create a source directory. We'll call it verbose.js. How about that? So I'm going to write a verbose piece of code. So I'm going to say a constant numbers is equal to, let's go ahead and say list of numbers 1 to 10. I want to start with those numbers right there. So given these numbers, I want to say let result is equal to 0. I want to output the result when we are done. Now in this case, I want to say a for, and let's say in this case I equal to 0, I less than numbers dot length, and then I plus plus. And then let's say result plus equal to, if numbers, let's say, of I mod 2 is equal to 0, then and only then result is equal to numbers of I times 2. So I'm doubling all the even numbers in this collection, and I'm totaling it. You can see the result is 20. But the question is, how does this feel? So this is imperative style code. We tell, in this case, what and how to do it. So how does this feel? That's a question I want to ask. How does it feel to write this code? And the answer is, all the details are on your face. To know what the code is doing, you have to read all the code, right? How do you feel about it, right? You say, hey, what's this code doing? Oh, let me figure it out. And you have to read the code and then say, okay, now that I've read the code, I can tell you what the code is doing, right? Would you agree that that is time consuming, right? That's a lot of effort. So if you want to think about metaphorically how this code feels like, every family has that uncle, right? You know who I'm talking about in your own family. That uncle, you are in a family gathering, maybe a wedding or a baby shower, whatever it is. You open the door, you step out, and in the distance, you see that uncle. And you say, oh my goodness, the last time I said hello to him, 3 hours of my life was wasted. No, you're going to take the turn this way, right? And you'll go around and escape because you don't want to say hello to this uncle. Every family has that uncle, right? And that's a code like the uncle. Because the minute you go to that code, it drags you in, holds you down, and spends time discussing things. And you're like, to understand that, you got to sit through the whole code. You got to read through the whole code. That is a lot of complexity. I think the code is complex. What do you think? Yeah, it's complex too, right? But question is, what does Plato think? So npm run Plato, and it says done. Let's open report index.html and take a look at what that says. Hey, that gave us, oh, by the way, If you're interested, that's how you make Indian bread, right? That's beautiful. That's one of the reasons I love JavaScript. It's the only language that is used to make Indian bread. Every time when I'm hungry, I run JavaScript code. That didn't go really well here. Let's take a look at why. Obviously, I didn't configure it properly. Let's go fix it, right? So let's go back to this. And let's go ahead and say Plato. So I want to say in here Plato, let's say Plato and then minus D minus R maybe. Let's try that. Maybe I can confuse the option over there. Let's run Plato and see if it tells us something a little different this time maybe. And we can take a look at what it says. No, it's still not working. Did I do something wrong?
What did I do directly?
Oh, it's not in that. Oh, thank you. That would be nice. Good job. You restored faith in pair programming for me. Thank you. That's awesome. So let me fix that really quickly here. I messed up with an option over there. I'm going to get rid of that one right there. So I'll move it to a trash. There you go. So you're right. I was sleeping at the wheel and you are very attentive. I love that. That's great. So let's go ahead and move that to the source directory and let's run npm. Let's see if that gives us anything again, and maybe we can take a look at what it tells us. So open report index.html, and okay, so I need to fix the other one that I did, right? So let's go back to edit package.json and minus D. So let's go ahead and fix that one. Is going to be a minus R, I think. Again, assuming I did that right properly. Let's do npm run Plato. Let's open the report. And finally, right? So look at what we have. I'm going to blow this away and recreate it so we can get a nice representation here. So blow that away, do a npm Plato, and do a open on it. Let's take a look at it. Now, so let's take a look at what you see here. It says the maintainability is a 65%. I don't know if things have changed a lot, I think. I don't know how universities grade students these days here in India. I teach part-time in Houston, and in my classes, 65 is a F. But the good news is nobody makes an F in my courses. My students are very smart. If they find out they're going to make an F, they drop the course preemptively, right? So I love my students. That's why I never give F, because they drop the course. Like, I drop it, you can't give me an F. Cool. So that's 65 is an F. That's not a good grade, right? So that's not going to work really well. We need to do better than that. So let's go a little further and see how we can make this better. So let's go back here and work with the code. So I take the source, verbose, and I'm going to copy it over to, let's call this as functional.js. So here's the functional.js. What does the functional.js do is the question. So the functional.js, so let's go ahead and edit the functional.js. Notice I'm going to say constant result is equal to. Hey, that's an improvement already, isn't it? So this is a functional style code. What are we going to do? I say numbers.filter. And in this case, we're going to say a function takes a number and return number. In this case, number mod 2 is equal to 0. So that is the filter function. Then I'm going to say the next step here is a dot map. And here's a function. And I take a number again as an argument. Return number times 2 is the second step I take. Then I say reduce. And what am I going to do with the reduce function? I say function total comma, let's say number, and I'm going to return total plus the number right there. So in this case, as you can see, we are writing the code in the functional style. And when you run the code, the result is still the same. So the code is, more concise, right? That's really nice, isn't it? The code flows like the problem statement. So you can read top down in one shot. So that's basically the benefit of this as well. So the code is a lot better, isn't it? So better, but it is still, I would say, noisy. So this is nice, but I'm not going to tell you I'm very happy with it. I'm not very pleased. Well, it is better, but not the best. What does Plato tell us? That's what I want to know. So let's do an open. This shows you a trend, by the way. So you were in 65, now it says 79. But if you look closely, what you notice is you had a 65% right there, you can see. From 65%, you went down to 93.56%. Talking about my class, 93% is a borderline A. If this is the end of the semester, you got an A. If this is middle of the semester, you're not going to get an A in the end. You're going to slip into 92.99 or below, which is a B plus. Oh no, A minus. You're not going to get an A, you're going to get an A minus potentially, right? So you don't want to be in that borderline. You want to be above 98 if you want an A. That's really borderline. So you want to do better. So yeah, this is better, but maybe we can improve this even further, right? So let's see what we can do. I did say this is a little bit noisy, so how can we make this a little less noisy? So let's copy over the functional to arrow.js. So source arrow.js, and in here, I'm going to say it's more concise. Code flows like a problem statement, read top to bottom, and it's better and less noisy than the previous version, which I've not written yet. We'll come to that. So what am I going to do? I'm going to use an arrow function. So remove the function from here, remove the parentheses from those, and you can then come down here, and where the curly braces are, you can put a little arrow, right? That's why it's called the arrow function. So now you can remove that right there. You can remove that noise right there as well, and you can remove that as well. So when you run the code in this particular case, so you have a number and you don't need the returns anymore as well. So that becomes less noisy, and you can see it produced the same result as the other one. So you can say, yay, that's definitely much better, right? So better, but still I am not happy. So why am I not happy? Because I still have to read the code with some effort to know what it is doing. So I am going to say this is not the best piece of code one could write. But let's go back and see what Plato wants to tell us. So I go run Plato. I open the output file, take a look at it. Now it says you're better, that's great. But if you look at it, we went from a 65% that we saw earlier down to 93.5%, down from that. And what happened in here? From that, we went down to what it considered to be 100%. I am like, no, that doesn't deserve 100. But Plato thinks it should be 100, which is still okay in my opinion, because the next code I write, if it says 110%, I'm okay with it, right? That would be only fair, isn't it? But it says it's 100%. But why am I not happy with this? So I'm going to go back here to arrow, and I copy that to concise.js. So let's go to concise. Now when you look at this code, what is the problem I have? The problem I have is, if you want to know what you're doing, you say, hey, filter, but filter on what? Oh, I see. You want an even number. Map doing what? I see you're doubling it. Reduce to do what? I see you're totaling it. Notice you still have to stare at that. We can agree it's a lot better than the imperative style code. Yet, you got to read that code a little bit. Now, this is where you have to be thinking about how to make code more effective. There is one principle I really like a lot. That principle is called a SLAP. SLAP stands for Single Level of Abstraction Principle. So single level of abstraction principle. So a SLAP is single level of abstraction principle, and it says a piece of code should focus on one level of abstraction. So anything that is a lower level should be delegated instead of being implemented in place. So in other words, don't do what is a lower level work, instead delegate it. So what is the benefit of delegation? You don't waste your time to understand. You can also reuse the code. It also becomes easier to test it as well. So what I'm going to do in here is to go back and say constant. Well, first of all, notice the code is still running, but I say constant right here is even equal to, given a number, I'm going to say number mod 2 is equal to 0. Likewise, I say double, and so I have a double and I have a sum or an add function, right? So we'll call it add. So the double function simply says times 2 and returns it. And here is the add function, and I'm going to say, a number 1 comma number 2, and I'm going to simply return from this number 1 plus number 2 and return it. So now that we wrote those functions, I'm going to go back here and say, hey, here is a filter, and in the filter function, I'm going to simply say is even. And then here is the map, I say double, and here is a reduce, I say add, and I'm going to run the code. Now notice the benefit of this code. When you come in, you can read these names and it tells you what it is doing. You can unit test these functions separately if they are important to be unit tested. But when you come to this code, what does it do? Oh, filter out even numbers, map to double of the values, and total it, right? So it became easy to read it, and you're not spending time understanding what those steps are. So this is basically applying the slap principle, and the code becomes very expressive. So even though all the 4 pieces of code are doing exactly the same, I would say one is more civilized than the other. So you can write the code in a way it is easier to understand, easier to maintain as well. And so that would be my preference. Now, of course, the question is, what does Plato think? And sadly, Plato says that that is 100% as well as the other one was. That's what it tells you here. And so that is basically 100%, as you can see, it's set for the arrow function. Likewise, it said 100% for the concise function, not 110 as I would prefer. So while tools are really useful, sometimes you have to go beyond the tool as well. So it can get you so far, and then you can still put some effort to make it better. So that is my recommendation on how you can make the code a lot easier to understand. So yes, you are using functional style, but I would recommend using functional style along with using things like slap so we can make the code a lot better. In a similar way, there are a few things you can do to make the code more easier to understand. This is, again, I would argue, comes down to discipline more than anything else. You probably have seen code like this. You have a code like operation, so a do work, let's say. So you have do work, and then they have as a first argument, you have some data, comma, function, and a result, and then you have a code that runs many lines like that. You probably have seen code like that, right? Comma, and then function, error, and then you have again code like this, which goes to many lines, and you're handling the error, and then comma, some other thing like a log, and you have a function to log, and some info you get here, and you have many lines over here as well, and you're going to see a lot more code like that. Now, have you ever seen code like this, where people take this parameter list and they drop a function right there, right? Now, what is the problem with this code? You have really hard time understanding where things start and where things end. You are like, okay, I have this function, and you're reading through it, and at the end you realize there is another function, right? And then at the end of that you realize there is another function, and you feel like you're tired reading through this code because you don't know where things begin, where things end. It becomes very complex. So my recommendation is avoid writing code like this. It doesn't take a lot of effort to write good quality code. It only takes very minimum effort. So what would I recommend doing? I would say, rather than creating a monster like that, get rid of all of that monster and simply say, do work, data, comma, you can say handle, pardon me, response, comma, handle error, comma, log. So then you can write a function called handle response, which takes a response like so, and that is a separate function, and it contains that code that we talked about a few minutes ago, right? And then you have a function, handle error. And what does the handle error function do? It takes an error, and like it did before, it contains all that code you saw. And then you can have a function log, which takes the info like it did before, and it's going to contain all that code. But the beauty of that is, when you look at this code, immediately you know what it is doing. You're like, oh, we're calling the do work method, and we're passing these functions. Not only that, you can take those functions and you can unit test them separately as well. You can unit test the do handle data, handle response. You can unit test handle error separately. So this is again using slap, and the code becomes easier to understand, easier to read. And we all have seen bad code, but the problem is, when you see bad code, if you don't recognize that it's a bad code, you mimic the bad code. Then it becomes a practice and a pattern. But if you say, whoa, I see what you have done over there, but we can write better quality code. And when you start writing code like this, your colleagues will look at it and say, huh, this one is actually easier to understand than the other piece of code, isn't it? And they may start reciprocating that, and they may start writing code like the way you do, so we can promote good practices. You know, often people ask me the question, how do you convince people to do the right thing? That's the beauty. You don't have to ever convince people. You do things so well, they want to do what you do. They want to imitate what you do. And if you go to them and say, let me tell you how you can write better code, like, who the hell are you, right? They're not interested in listening to you. But you write really good code. You smile when you walk around. You're not sitting there and debugging code late in the night. And you just write code and you walk with grace. And they're like, what does he or she drink? I want to have that, right? Because they want to imitate when they feel like you're successful. So don't try to convince people. Just convince yourself that this is a better way to write code, and do it. That's the key. And that is the key. I once went to a company where I was shocked, honestly, because their architect sat there. I was teaching a course. I was showing how you can use test cases. And their architect tweeted saying, I really hate unit test. Imagine if you're a leader in a team, and that's a message you propagate to the rest of the team. No wonder nobody in their team wrote any unit tests. No wonder they couldn't release product on time. They were always delayed and they had thousands of bugs to deal with. The leadership matters, right? So if as a leader, if you don't promote good practices, how do you expect others to follow, right? So that is the key, is just start doing good things and others will start, following it as time goes on. So don't make the code hard to read. You don't have to really provide all that function in the parameter list. You can write a separate function and you can pass it around. That becomes really easy. Similarly, review code. Code reviews are a great way to really improve the quality of code. But how do you review the code? The worst way to review the code is to bring the team together into a room, post the code on the screen, and you start critiquing it. That is not code review. That is where people get insulted, right? So the next time you say, hey, we're going to have a code review, the person doesn't show up. They say, I have enough sick days on my calendar. I'm going to take leave on that day because I don't want people to be insulting me by looking at the code. And the other person is, I already have enough things to do. I don't want to go there and look at the stinking code that somebody else wrote. So that's not a very productive way to do it. But we use code review a lot. The way we do code reviews is very tactical. When I finish writing a piece of code, one person reviews the code. The next task I work on, another person review the code. So we just let one other person review the code. I call it a tactical code review. And that one person reads the code, writes down a few notes on it, and then gives the response back. And then I can go back and look at those considerations, evolve the code, and I can move forward. It doesn't become charged with emotion. Instead, it becomes a very positive feedback. That's one way you can improve it. Another way you can promote good quality code is to really do active pairing. If you find that somebody is writing poor quality code, don't go to them and say, you know what, do you realize your code smells worse than the garbage truck, right? That is not a way to help them. They're not going to be your friend after that if you tell them their code smells worse than a garbage truck, right? Because that's an insult to garbage truck drivers, right? You don't want to do that. So as a result, you want to really say, hey, I am looking at this code, should we just refactor it? And they're like, why should we refactor it? Well, the reason to refactor is this function is doing two things. Maybe if we apply the slab principle, we can make it easier to maintain. What do you think? And they're like, well, I'm not sure. Well, why don't we pair up? You can sit down with them and we can pair up, and that's a great way to learn. And the chances are you will start pairing up. And one of the reasons I often pair with people is not because they can learn from me, because I want to learn from them. Invariably, I learn something when I pair with people. I'm always like, whoa, what's a shortcut you used over there? Ooh, what tool did you use? How did you arrive at that conclusion? So we end up learning from each other. That's one of the biggest benefits of pairing, is it makes both of us smarter. So that is a very nice way to do. Write unit test. Unit testing is a great way to verify the code is working, but it also makes it easier to modularize your code. A code that is poorly designed is a code that cannot be easily tested. So that's one of the reasons I write unit test as well. And then, like I mentioned earlier, you can use tools to improve the quality of code. You can use tools like ESLint, and you can ask it to verify that the code is working properly as well. So that can be very useful to get that kind of feedback, if you will. So for example, let's say in this particular case, I want to make use of a little example here. We'll play with it. I'll get rid of this first. So I want to go back and bring in a little example and play with it to just see how this would look like. So back here, I want to bring in a little, let's say, a package.json. So let's just copy it over. So in this package.json, I'm using ESLint. I'm going to run ESLint. So I'm going to say a sample.js. So within the sample.js, I say something like let A equal to, let's say, 1, let B is equal to 1.0, and I'm going to then say output A is equal to B, for example. Or I say var, let's say Z equal to 32, and I want to output the value of Z, let's say. So you can take a code like this, and what you can do is you can say npm run ESLint or npm run lint. So you can look at the lint output and what does it say? So npm install before that. So you can install and run the lint and see what it wants to tell you. So if I run the lint, it can give you errors, right? Well, in this case, it says, oops, something went wrong. But you can take, oh, source is not found. So let's do a source and then move the sample to source. Let's see if that actually helps, and go back and run the code again. And there you go. So notice it gives at least one error. It says parsing error, unknown token A. So it is complaining that something is wrong on line number 1. Not exactly sure why it gave that error, but you get the point, right? You can use tools like this to get feedback on your code, and you can run through them as well. Like I also showed you, I can for unit testing, I often use use Jest these days, but you can use any of the other tools available as well. Like I said, Plato is a great tool to use for measuring cyclomatic complexity in code, and it gives you a value between 0 and 100. You can improve the code, and then you can rerun Plato and see the trend your code is taking, and you can make sure that you are improving the code every time you refactor as well. And the last thing I'll mention is I have these tools running as part of my continuous integration. So as I run my code in continuous integration, what you're going to notice is when somebody commits the code, it first runs all the tests. If the test fail, the build fails. If the test passes, then I run ESLint. If ESLint fails, my build fails. If ESLint passes, it runs Plato. And in my case, I have a little script that goes and looks at the output file that Plato produces. And it turns out it's just a JavaScript object in that file, report file. I showed you the index.html. It produces a JSON file behind the scene. I have a script that just loads the JSON file, and then I look for the metric. If the value is less than 70%, I fail my build. In some projects, we even bump it up to 80 or 90%. So you can play with that nicely and get that feedback, and you can improve the quality of code. Hope that was useful. That's all I have. Thank you.